Right, so we've covered, so far we've covered just taking a look at the concept of a stateful firewall, looked at the concept of creating sessions, the concept of a flow, and we looked at the fact that with a stateful firewall, what happens is if the traffic is allowed to create the connection, then the return traffic for that connection is also permitted. We looked at zones. I looked at zones being one of the basic building blocks of setting up our security. And now we're going to take a look at security policies. So between zones and policies, we've really got the foundations of really setting up a firewall. So what we're going to do, we're going to take a look at the function of a security policy. We're going to look at these things called ALGs, or application layer gateways. Look at the components of the security policy, look at verifying policies and monitoring their execution, and we'll get into configuring a basic policy using the elements that we would normally use, such as policy match conditions, policy actions, and we're going to look at scheduling as well. In other words, putting or having a policy either active or inactive based on a particular time, so a day of the week, a time of the day, some of those parameters. So let's get in and have a look at this. So first of all, we're going to look at the security policies themselves. And what is a policy? Well, it's a set of rules that tells the device, SRX, what to do with transit traffic between zones and transit traffic within a zone. So what do we mean by transit traffic? When we say transit traffic, what is that? Basically, what do we mean? What is transit traffic? Basically, it comes in on one interface and goes out on another interface. That's transit traffic. It's transiting the device. What would traffic be that was not transit traffic? What's an example of traffic that's not transit traffic? I mean, most traffic is transit traffic, right? It comes in on one interface, it goes out on another. That's pretty much will be the normal operation. What is non-transit traffic? Well, non-transit traffic would be when you set up an SSH session to the device to manage it. So that traffic is going to the device. So it's not transiting the device, it's actually destined for the device. So security policies are evaluating transit traffic, not traffic that's going to the device. Okay, so you actually can't set up a policy to control traffic that's destined to the device itself, not using security policies. Okay, so here's our graphic. So we've got traffic coming in on the ingress, and we can do the usual things. We can put firewall filters on it, we can put polices on it if we need to, all the usual stuff. And then it goes up into our flow models. And what we're looking at now is the policies and the application layer gateways. Okay, so the Juniper operating system running on our SRX is going to examine transit traffic by using policies so the traffic comes in. And it always has to ask the question, does a security policy match the traffic? And if it does, then we'll apply the policy actions. And if it doesn't, then we'll apply the default policy. So, what is the default policy? What would the default policy be? Let's just say we've got two zones, zone A and zone B, and we've got an interface in each zone, but we have got no policies at all written, defined for what happens with traffic between these two zones. Absolutely nothing. And we've got traffic that comes in on interface in one zone, destined to exit on an interface in the other zone. So it comes in on zone A, it's going out on zone B. What would happen? What is the default policy? Well, as it happens, the default policy is to deny everything. So basically, there's no traffic going anywhere between those two zones unless we actually have a policy to allow it. Now, here's a very important point. The same goes for network segments within a zone. So let's just say I have a zone, I call it my internal zone, and I have got a network segment in that internal zone, and I decide to create another network segment because I need to, well, maybe I just need more addressing space, I need to put another department maybe over onto that particular network segment. So I go ahead, I create another network segment. There we go, happy days, got it configured up, it's all looking good, and suddenly I can't get any traffic to go between my two network segments in the same zone. Why is that? Well, because the default policy for intra-zone traffic, the traffic within the zone, is also to deny everything. Okay, so I'd actually have to write a policy that says from zone internal to zone internal, they are all on those lines. Okay, so quite an important point. Now we have. Let's take a look at this this host inbound traffic that we looked at when we the incoming interface. What does that mean? How could a packet be destined to the incoming interface? That would mean that the destination address in the IP header was the same address as the address configured on the interface. In other words, you are creating a telnet or SSH session, or maybe a HTTP session to the device. So that's you, the administrator, connected to the device. So if that is the case, then what happens is we don't evaluate any security policies at all. We'll go straight down to this last question, which says, is system service or protocol allowed into the interface of the device? So that is our host inbound traffic configuration. So okay, I'm trying to establish an SSH session with the device. I'm trying to establish that on one of my interfaces. Is SSH actually allowed into this zone in which this interface resides? If it is, yep, we'll set up the session. If not, then that traffic will be denied. Connection will be refused. Okay, so that's the first scenario, that the packet was actually destined for the device itself. That's you connecting to it, you setting up a management session to the device. The other scenario is we get to the question, is the packet destined for the incoming interface? And then the answer is no. No, it's not. In other words, this packet is transiting. It's going somewhere else. It's got another destination. So the answer is no. Okay, so the next question is, does a security policy match the traffic? If the answer is no, we apply the default policy. In other words, deny everything. It's not going anywhere. So if the answer is yes, then we apply the policies. Does the policy permit the traffic? If the answer is no, we drop the traffic. If the answer is yes, then we go through to the last question again. Is that service or protocol allowed into that particular interface based on the host inbound traffic configuration? If the answer is yes, then it is permitted. Okay, so that's the flow of how it all goes. Default security policy. So the default policy is to deny everything, as I just mentioned. And of course, you can change that to permit everything or whatever you like, whatever it needs to be. So, system default policy. In other words, if there is no policy configured at all between zones, the default is to deny everything. If you go and either load the factory default or just buy a brand new device and unpack it out of the box, you'll have a factory default. The factory default will have a policy. It comes with a policy with some zones set up. One zone is called untrust, the other zone is called trust. and you'll have your VLAN 0 sitting in trust. I think it's GE001 is by default sitting in the untrust zone memory. And the default policies are trust to trust, with everything, so that's within trust zone. That's the default policy. Good question. Would the device actually work? So if I actually put an internet connection on my untrust zone and hooked up an internal network to my trust zone and then had some devices on that, would it work? Could it work? Would that policy allow me to say I'm sitting here in the trust zone? Would that policy, and I say I had an internet connection in the untrust zone, would that policy allow me to get an internet connection? Would it work? Trust denial. So anything from the trust can go out to the untrust, but nothing in the untrust gets back into the trust. Would that work? I will leave you with that question. Okay, so there we are. We can see that from the untrust back to the trust, everything is blocked, nothing is back in. Okay, so here we go. Let's take a look at this concept here. So here are the steps. Step 1, host B initiates, for example, an SSH session. Could be anything, but let's just say host B initiates an SSH session to host D. So there we are, host B sitting over there in the private zone, and here we have host D up here in the external zone. So shows the big up there, the internet's in that zone. So here we have a host B initiating the connection. The security policy permits that flow. So we say, okay, let's look at the policy. Yes, the policy says SSH is permitted. Yes, that's all good to go. Lovely. 3, the flow triggers a reverse flow creation. Both flows result in a form session. So in our session table, we have this new session being created with the flows in both directions being permitted. And the return traffic, host D and host B, also receives permission. Okay, so that's stateful firewall processing. Okay, so going back to my previous question, just out of curiosity, in this situation here, if I had an internet connection in the untrust zone and I had devices in the trust zone, could my devices connect to the internet with that configuration?
I think no.
You know? Okay. Why would they, or why wouldn't they be?
Because I think you go, it's from internet and then return to the trust.
So let's say the internet's over here in the untrust and all my devices are over here in trust. Can I get an internet connection?
It's like the last rule. Deny all.
Yeah, we do have a deny all coming back. So what I'm saying is nothing is allowed from untrust into trust. That's my policy. The policy says everything is denied. Okay, we'll come back to that. Okay, so policy ordering. The order in which policies are written are important, or order in which they occur in your configuration is important because they are evaluated in order. So by default, new policies will go to the end of the list. So if you wanted that policy to be evaluated before another policy, you can change the order using the insert command. So here we go, as an example then. Insert from zone to zone name, policy name before or after another policy. So you can use the policy name to insert a policy before or after another policy. Okay, so editing security policies, so like any other configuration stanza, you can perform the following actions on the policy. You can delete it. So we don't need it anymore. You can deactivate it. I found that to be a very helpful feature, the deactivate feature. You may have a policy that you've written, but you don't want it active at the moment. Or maybe you don't want to have it, maybe it's been active, but you don't want it active anymore, but you don't want to delete it because you may want to use it again. So you can simply go in and deactivate it and commit the change, and then the policy is no longer evaluated. Of course, you can activate the policy that you have previously deactivated. And we looked at insert, you can annotate, so put notes on a policy, you can copy a policy one to another, you can rename a policy, and you can search and replace words or phrases within a policy. Okay, so we're going to look at security policies. Let's go back to this question again. I want to answer this question before we move on. The question was, if I had an internet connection in the untrust zone and I had my devices in the trust zone, could I actually have a functioning and working internet connectivity to my devices? And the answer is yes, I could. Because the important thing on the firewall is, where is the connection initiated from? The connection is initiated from the trust zone, going to the untrust zone. Therefore, if the policy permits that connection, which it does, then a session will be created also permitting the return traffic for that connection. So even though my policy says everything from untrust to trust is denied, I'm letting nothing through at all, in actual fact, I'm letting all the return traffic through from anything initiated from within the trust zone. But if something is initiated from the untrust zone to try and get into the trust zone, that is not getting through. Okay, there's no way that's getting through. So it's really important as to where is the connection initiated from. If it's initiated in the untrust zone, nope, it's not getting in. Initiated from the trust zone, yes, the return traffic can be moved back in. Okay, so let's go and look at that next topic. Next topic is application layer gateways. So let's look at what these are. Software processes that manage protocols. Designed for each protocol and operate differently. The protocols usually use dynamic client and server ports for different parts of the communication. So here's a scenario. Remember when we are creating a session, what we are evaluating, you can evaluate the source IP address, the destination IP address, the protocol is the TCP or is it UDP. We're looking at the application layer port numbers, so source port, destination ports, and maybe port 80, wherever it is. And then we say, okay, yes, we're permitting that. Let's create a reverse flow for that. So we're going to have the source address on a reverse flow. We're going to have the original source address being the destination address, the original destination address being the source address. We're still using the same protocol, and we're just swapping also the application ports around. So we're allowing traffic back in on the same application port that we allowed traffic out. Okay, here's the issue though. You have got protocols that will establish a connection using one port, but actually require data to come back on a different port, which we have not allowed in our session table by default. There's lots of applications like that. FTP is an example of that. FTP uses port 21, as you know, to establish a connection. However, that is the control channel on port 21. The actual data flow on FTP comes in on port 20. So when we establish a connection with FTP, we really need the return traffic to be able to come back on port 21, but also we need port 20 open as well, because that's where our data is coming through on port 20. So our control traffic's on port 21, but our data is coming back on port 20. So we have a problem in that by default we just left things to sort of work as they work. With our session table, we would not open up a return port for traffic coming in on port 20. This is where the application layer gateway kicks in. The application layer gateway recognizes the fact, this is FTP going out on port 21. I recognize that as FTP now, therefore I know I need to open up what's called a pinhole on port 20 to allow the data to come back for that particular session. It will create, in the session table, it will actually open up a flow for return traffic on port 20. And there are a number of protocols that are like that. Quite a lot of them. So we'll have a look at examples of some of those. So here we go. This is the FTP example. So this is the trust to untrust. We've got the sync session going on there, which is using TCP. There it is on port 21. Lives out there on the FTP server. So this is the handshake, this is the sync act, and act coming back. All good. That's all happening on port 21. Then we've got the return traffic, which is actually the data traffic, needs to come back on port 20. So this return traffic now is coming back on port 20, for which we never had any outgoing traffic at all. So by default, we would not have opened up port 20. That's what the application layer gateway does for us. It opens up a pinhole, it's called a pinhole, on port 20. So if we take a look at the session that we have created, we actually have got this FTP session here, and we've got return traffic happening on port 21, but then we've also got port 20 open as well for return traffic on 20. So we're actually creating two sessions in that case. The AGL will automatically create this additional session to allow the traffic to come back on port 20. Okay, so if we didn't have an AGL, we'd have to have another security policy to allow port 20. But the AGL does that for us. Okay, so there are a whole range of predefined AGLs already built into the GNOS operating system. We don't have to build our own. We can build our own, but you don't have to. They're already defined, already in there. We can take a look at them with the command show security ALG status command. AGLs are called ALGs. Okay, so we can take a look at that command. We'll see that there's DNS, FTP, H2, 3, etc. There's a whole host of them. And they are invoked automatically. So if you configure a security policy to allow one of those protocols in your policy, then the ALG will automatically be invoked when traffic matches that policy. You can edit them. You can disable them if you want to. Put trace options onto them to see when they're actually being invoked. Here's an example of us applying the policy. So apply AGL under the edit application name hierarchy. Associate an ALG with an application. They are already by default associated. You don't really have to do it. It's just kind of making you aware that they exist. That's what they do. When you see these dual sessions being set up, it's the ALG that actually is doing that. Okay, we'll have a look at an example of some of those when we get in and look at our gateway that we're using, and we'll see those ALGs being activated or being part of the policy. Okay, so let's go. So we're going to look at the components of security policy. So we create the policies under a context, so they are from zone to zone. So when you create a policy, you're going to go in and edit security policy from zone to zone. So you've set up your zones. So the first stage of your design process is to figure out what zones do I need. Okay, now the decision for what zones do you need is based on the question of what are security requirements for my network segment. If the security requirements for one network segment are identical to another network segment, they can belong in the same zone. If they are in fact different, then they are probably better off in a separate zone, where you can treat them separately, have different policies for that particular network segment. And that will come back to the types of protocols that you're using within that network segment. As I said earlier, you may have a web server, you may have a unified comms server, a VoIP server, you may need SIP and RTP, you may need HTTP, HTTPS into another zone. So it kind of depends what are you doing in that with that particular network segment. So that's the first stage, is figure out what zones do you need, design your zones, and then decide, okay, what am I going to allow from this zone into that zone? So if I have something initiated from this zone to try and establish connection into this other zone, what am I going to allow to be initiated from one zone into another zone? So that's when we set up our policies. So we're under the hierarchy of edit security policy. So we're really going edit security policy from zone to zone, and that will land us pretty much down at the hierarchy where we need to be to start writing those policies. And then we can start to go in and say set policy, give it a name, wherever it is. Just give it some kind of a descriptive name for your policy, and then we're going to set up some matching criteria. So we're always going to include a source address, a destination address, and an application, even if the source address is any, and the destination address is any, and the application is any. Okay, so we could be just allowing everything. We could just have just everything. We allow everything. Just say we're going to say trust to untrust in our previous example. We could just have source any, destination any, application any. So we're allowing everything from the trust zone to go to the untrust zone. And then the action, we could have commit, deny, reject, log, or count, or a combination of. You could permit and log. You could reject and count, or reject and log. So you can combine, these things. What is the difference between deny and reject? We know what permit means. That's pretty obvious. What about deny and reject? What's the difference between deny and reject? With deny, the packet is dropped silently. With reject, it sends an ICMP message back to the source to identify that it's been rejected. And then we can log and count, log all count, log and count any of that traffic. Other things that we can do with policy actions is we can invoke other functions. So within our policy, we can invoke, say, traffic going from here to here that we are permitting. We can invoke IDP, which is intrusive detection and prevention, which actually sets up that whole system. of IDP to evaluate traffic that matches that policy. We can set up UTM, which stands for Unified Threat Management, and UTM includes things like antivirus, content filtering, so we can be referencing a virus signature database where we're scanning traffic based on virus signatures. We can be doing things like content filtering based on a classification system that you may be referencing, maybe an online classification system that has classified different sites into different categories, like different sites may be potentially malicious. There may be some stuff that's just inappropriate content that we don't want to let into the organisation. So we can set up these types of things to block that type of traffic as well. So then the traffic that is permitted by a policy can be further evaluated by IDP, UTM, or this other little thing we'll look at shortly called firewall authentication. So we'll get into these later on in the course. Okay, so policy matching criteria. So we've got a source address, can be an individual address, or can be an address set. So it can be just one address, or it can be a whole group of addresses that we are matching on here. Now the way that you do this is you don't actually go ahead and type the IP address in the policy. What you do is in the zone in which the source address or source interface resides, in that zone, what you do is you go ahead and you create this thing called an address book, where you give the IP address a name. So let's just say the IP address might be FTP server, might be the name, and my FTP server's address is, in our case, it's 10.10.40.11. That's my FTP server. So I would go, and if I was, say, going to, just say we have a destination address of my FTP server, and that's residing in a particular zone. So in other words, the destination interface is in a particular zone. You go into that zone and you create an address book which says we have this entity called FTP server, and its address is 10.10.40.12. So in the policy, what you actually reference is the name that you've given it, FTP server, instead of actually typing in 10.10.40.12. Now, why would we want to do that? Well, what would happen if I had a number of different policies that reference that same particular server, and then I went to change the server's address? Well, all I have to do is go into my address book and update the address in my address book, rather than going through every single policy that had previously referenced it and updating every policy. So it's a simplification, really, of managing addresses and entities and so on. Okay, so so these address sets are things that we set up within a zone's address book. Now we have applications. They can be system defined or user defined. Most of the time you're going to use system defined applications because they are fairly standard applications. There are times when you do have to go in, and if there is no system defined application for the particular thing that you want, you do have to go in sometimes and define an application yourself. And I've had to do that. Remember, I needed to allow asterisks, IAX2 traffic between zones, and there just was no system-defined application for that particular protocol. So I just had to go in and define it, and then reference it in the policy, which is fine. It all worked very well. Okay, so let's take a look at these address book entries here. So these address books are set up under the zone itself, under the address book hierarchy. So we give it a name, like, as I said, FTP server, for example, and that in our case was 10.10.40.12/32 because it's just that specific address. And then you might have another name for something else that's in that zone. There's other servers in the same zone that you may need to reference in a policy somewhere, and you simply put the name of the server in, just whatever you want to call it, it's totally up to you, and then you give it its IP address. It might be a block. Maybe there might be a block of addresses that you need to reference. So you just give it the appropriate mask there. Alternatively, you can set up an address set. So with an address set, what it allows you to do, it allows you to group a whole bunch of these addresses and reference them all by a single name, which is address set. So when you're writing the policy, instead of having to put each and every name in the policy, you can simply put just the address set name, and the address set will include all the addresses that are part of that address set. So with an address set, you still go ahead and create all the names and all the addresses all the IP addresses that relate to those names, but you kind of put them under this address set. Just makes it just so much easier to reference them in a policy. So you're including a whole list of addresses in the policy. And the other thing is that if you need to include an additional address in that policy, you don't have to edit the policy. You simply go in to your address set and just add the extra address in your address set, and it's done. Very simple. So it's very, very simple to add an extra address into the policy. It's just a better way of organising entities and addresses that you're going to reference in policies. So you can create an IPv6 address entry as well. Just a little note here that if you're going to use IPv6 addresses, you have to go under the edit security forwarding options and family INET mode flow base. So you have to go and specifically enable IPv6 flow mode on the device. It's not enabled by default. Okay, once you go ahead and put that configuration in and commit it, you will get a little message telling you that you need to reboot. Okay, I found this to be a really, really handy thing. The ability to use a DNS name instead of an IPv4 address or IPv6 address in a security policy. I've had a situation where I needed to allow access into our internal networks to a particular individual. The problem was that this particular individual did not have a static IP address. They actually had a dynamic IP address. So the original problem I had was that I didn't know this. And so I said, okay, I'll give you access into our network to the particular server that you need access. What's your IP address? Oh, this is my IP address. Oh, good. Okay, so I set up the policy. And everything worked for about 2 weeks. And then I said, oh, my IP address has changed. I thought, oh, okay, maybe they changed the static IP address. So I went into the address book and added another address book. Everything worked again. Oh, happy days. I said, oh, actually, my address has changed again. And this went on for a while. And I said, what's going on here? I said, actually, I don't have a static address. I've got a dynamic address. Oh, okay. I said, wow, what can we do about this? I said, well, instead of referencing my address, why don't you put in the name of my connection rather than the address of my connection? that way, then my device, my SRX device, will actually go and do a DNS lookup of the name and obtain the address. And once I've done that, I've never had to update it again. Okay, so brilliant when the address keeps changing, the actual IP address keeps changing. Brilliant, you can go and put in the name, the actual name of the particular, here it is here, DNS name abc.com, whatever it is, okay? Of course you must have a DNS server, which you would have had a DNS server set up anyway. You're not going to set up your gateway and not tell it where to find which DNS server is, so that would be something you would have and should have set up already. And then it's just a great solution for situations where the name changes. So there we go, use a DNS name. Okay, we can define custom applications. As I mentioned, I've had to do that with the ACIT trunking protocol, the ACIT IX2 protocol. There are lots of built-in applications, lots and lots and lots of built-in applications. I would say there's probably 100 of them. They all start with the word Junos. But just say, if I wanted to enable FTP by policy, I wouldn't have to go and create or define the FTP as an application. That was going to be there because all the common ones are already there. In fact, a lot of the uncommon ones are already there. There's so many of them. So you just go and search on, you just put Junos FTP and it'll just come up. So there's lots and lots of applications already there. Junos SIP, for example, is there. Sometimes you'll come across, in fact, there just isn't one. You'll have to go and create it. Pretty easy. Go on the edit applications, give it a name, and then you just go ahead and define the details of that application. We're going to take a look at all the default applications. We're going to show groups, Junos default applications, and they'll all appear. We'll take a look at that. Do a demo on this shortly. Okay. Again, actually, you go and modify the built-in applications if we need to. We can change the port, we can change the timeout values. We can tell it to ignore an ALG if you want to. Sometimes, see, the thing is, why would you want to ignore an ALG? Well, sometimes they can create problems. I've had different vendor gateways that create all kinds of problems when you invoke the ALG, particularly on VoIP calls. So sometimes on VoIP calls, what the ALG will do is it will look inside the SIP packet to figure out on what ports the RTP stream is going to be coming back on, and it will open up that range of ports, and sometimes it kind of mucks it up and does all crazy things. I've had it sometimes where you hear everything twice, so the telephone conversation, everything is repeated, like hello, how are you, what's going on? And you turn off the ALG and it all works perfectly again. So sometimes they can be problematic. Okay, so we can alter the built-in applications. If you need to, usually you don't, but you can. Just an example that under the show security flow sessions extensive, we can see that the fact that we've altered the application, and we can see that we're using an altered version of the application. Okay, so let's get into the nitty-gritty now of setting up these policy match entries. So we would go into edit security policies from zone to zone, policy name, so the policy, in this case it's name 1. Okay, well we would actually give it an actual name. And then you would use the term match, and then you would write source address and give it the address name. Now the name you put here, remember that's not an IP address, you're not typing in 10.10.40.12, you're typing in the name that you originally put in your zone address book. So you would put in my case, FTP server. You would go there in address name. Destination address, exactly the same. You create another address over in that zone, and you're referencing that address there. And then application name, if this was FTP, you would have Junos-FTP in there. Okay, because what you do is you would go application, and what you can do is then type in a question mark, which will give you all the possibilities that you can put into there, and you go searching through, and you say, that's the one I want, Junos-FTP, and then you go and type that in. Okay, so that is a match test. It's policy. We've got a match. We actually are missing our actions on this. We'll get to that. We're just looking at matching. So source address, destination address, and applications. There's our matches there. Then we have to put some actions in to a policy. We're going to permit it. We're going to deny it. We're going to reject it. We're going to log it, we're going to count it, or do we need to do something else with it? Do we then feed that traffic through into an IDP or maybe a UTM process of some kind? So here's some of the, so basically these are the action permit and object. What we can do with permit, we can then feed the traffic through or feed that into another process with our permit. So we can configure firewall authentication, authenticate the client prior to forwarding to the traffic. What that does, it says, yeah, okay, I'm going to permit the connection from this network to a particular server, for example. Say it's my web server or whatever it happens to be. Maybe it's some more confidential information on that particular server or whatever it is. You can say, yeah, I'm going to permit it, but what I'm going to require from you is a username and a password in order to connect to that particular server. So you can actually make somebody enter a username and password, or invoke some other form of authentication to ensure that they are in fact allowed to connect to that server. We can actually set up a policy-based VPN. So there's two types of VPNs that we can create. Excuse me. They can be policy-based or route-based. So this is an example of setting up a policy-based IPsec VPN. So we say, well, if traffic matches a particular policy, then we're going to feed that traffic into a VPN. And so that's one of the things we can do with the traffic. We can invoke IDP. So we'll say, yes, the traffic matches, we're going to permit it, but we're going to feed it now into this IDP process and perform IDP policy evaluation, intruder detection and prevention. We can perform UTM with it. We can perform both of it actually if we wanted to. So we can go things like antivirus, web filtering, content filtering. So all these things are possibilities and options that we can do with traffic that we permit. Okay, so how are we doing? Got time there? Okay. All right, so let's take a look at these user role firewall policies. We get to classify traffic based on roles. So we can set up this agentless transparent authentication, and we need support from another device for that. In actual fact, this is one way of doing it. Have this MAG series device which will then authenticate the traffic through, so the user's credentials are put into another device, which then you use to authenticate that connection. So the person has to actually enter in some kind of credentials to establish the connection. So you can set that up inside of a firewall policy. Okay, let's look at this concept of global policies. There's a single security policy that allows traffic from any zone to any other zone. So in other words, when you configure it, you don't put from zone to zone. You configure it under the Edit Security Policies global policy. Basically, what it can do is, if you've got a number of different interfaces in a number of different zones, and you want to allow traffic between them, you can go ahead and configure a global policy which kind of replaces maybe 3 different policies that you might otherwise have to configure to allow that traffic. So, and your addresses that you're using are in the global address books. They don't belong in a particular zone. They're actually set up under the address book global hierarchy. So it's where really we want to allow traffic to go between a number of zones, and it's just to save the resources of the system to have to maintain policies for a number of different zones, when you can probably do it all just with one global policy. It's kind of where that fits in. Here's an example here. It says if source IP address is host A, host B, or host C, and the destination address is any, and the application is HTTP, then delete the traffic. So what we're saying is, well, we're going to allow any HTTP traffic through that policy. And it just says having to write 3 policies to achieve the same thing. So it's kind of where you pretty much want to allow something amongst a number of different zones. What we're saying is, well, we're going to allow internet access for everyone, regardless of the zone that they're in, and just go ahead and write the global policy. So let's have a little summary of the components of a security policy. So we've got it written under the Edit Security Policies hierarchy. The context is always from a zone to a zone. That's the context of the policy. The policy has got a name, which you make up. You decide what the name is. The next criteria is match. You're going to type match, and then you're going to put in the source address. You're going to put in the destination address, and you're going to specify the application. You must have those 3 things in your policy. The next thing is you're going to define what the action is that's going to be taken once a match on those 3 criteria has been made. And then you go ahead and you put in the next policy. So policies are evaluated in order, the order in which they are written. So, for example, if you had a policy that said, well, I'm going to have source address, destination address, and application down here is FTP, and I want to deny that application, you would need to put that first before a policy that had the same source address, the same destination address, and an action which said permit all. Okay, you have to deny the FTP before you permitted everything else. So the order is important. So here's our context, there's our 3 criteria, there's our action. Okay, how do we verify the operation of a policy? So we can log a policy, we can actually create a log for it. They are actually already logged in the syslog file. The syslog is the default file, default system log. The name of the syslog file is messages, as you may recall. So really it's logged in there in any case. Our syslog. We can go and edit that and define exactly what gets logged in our syslog file. High-end devices, data plane logging can go into an external logging device, so we can actually send that off to somewhere else and collect our logs from another server. This is taking a look at a log. This is got a date, got a time, RT flow session close. So this is session closing here. We've got some information about TCP fin, which is the finish flag on that particular session, and then that session was closed. So some information about there. Use the log action in a security policy, so we can actually log. Here's our policy. We've got set policy 812, then log. What we want to log? We may want to log session close, session init, or we may have some groups that we want to apply to that policy. We can count, so we can count traffic, for example, and those stats will go into a log. We can use the show security policies command to view the details about our policies. If we go to show security policy detail, then we'll see the detailed information about our policy. I'm going to give you an example of that. This is really useful. Show security flow session. So you're going to see a lot of information there. This is when you're using this flow session. It's really helpful then to use some matching criteria to find some exact information that you may be looking for. So you're looking for a particular IP address, or so that maybe you want to match on that. You can also use trace options. We've already covered trace options before. So this is the edit security policies. We can put a trace option on a policy. We can have trace options under the flow hierarchy as well. And we are looking at source addresses and destination addresses, so we can really go ahead and if we've got, that's really troubleshooting when we're doing this. We really want to troubleshoot a particular session or particular traffic flow to find out what's going on with it. Policy, scheduling, and rematching. Scheduling is a really interesting. I'll give you an example of scheduling. Here's an example of maybe scheduling. Let's just say that you've got shift workers in your organisation that come in after hours and maybe work at night. And with those particular shift workers, well, they've really got no business going to sites like maybe Facebook and Twitter and other social media sites. They've also got no business going to gaming sites and other types of sites that, have really got nothing to do with work. All right, so and because maybe they're not supervised at that particular time, or they're kind of not as supervised as people who work during the day, say perhaps, you might want to put a policy that says, well, I'm going to put a policy in place that from 6 p.m. at night till 8 a.m. in the morning, this particular policy becomes active, which blocks out all access to these particular sites. Set up a policy that blocks access, and you set up a scheduler that makes the policy active at those times. So it activates at those times and it deactivates at other times. It may be, there may be other policies. Maybe you want to disable some other kinds of functionality that you really don't need at certain times. I found this. I'll give you an example that I found this very useful. Okay. So a policy can refer only to one scheduler. Multiple policies can refer to the same scheduler, and a policy remains active without an applied scheduler. So when you have a scheduler, essentially the policy is active during the scheduled time. So it's activated and deactivated based on automatically based on the times of the scheduler. Now, of course, that means you've got to have your time set up properly on your device. You've got to put in the proper time zone. You've got to be using your net time protocol to make sure it's synced to a NTP server so that your time is accurate on your device. Of course, you want to do that anyway, but certainly when you're using a scheduler. So you can configure a scheduler with a start date and a time and a stop date and a time. You can also have a daily schedule with start time, stop time, all day, etc. You can have a scheduler which will say Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Start time, stop times, and all those start and all those times. There's actually it's quite easy. You can do this from the CLI, but you can also do this from the graphical interface fairly easily as well. If you log in with the graphical interface, you get to the scheduler kind of a little bit more visual, and you can see a little more clearly almost when your start and stop times are. I'll give you an example of a schedule that I have set up. Probably after we have a break, we'll go and take a look at that. I'm just going to look at some policies as well, some schedulers. Look at address books and just kind of get an understanding of how they work. Okay, so we can apply a scheduler. We just here we get policy, and then we go match, then permit, and then we'll have a scheduler name down here. We apply the scheduler into the policy. If they don't have a scheduler, then they're active all the time. If they do have a scheduler, then they're active when the scheduler says that they are active. Policy rematch signals that the application of a policy configuration changes to existing sets. So what that means is that if I go and change my policy and then commit it, by default, the sessions that are already established are not dropped, are not changed. They just remain active until they time out. And then only new sessions are affected by the policy change. But if I go and type in set security policies, policy rematch, then I go and change a policy, then all existing sessions that relate to that policy will be dropped, and new sessions will have to be created with the new policy rules. So that's all that really does. Okay. Personally, I've found scheduling to be quite a useful tool. Okay, let's look at a case study here. We want to create a policy between HR and public zones. So public zone there on the right and our HR zone there on the left. We've got a couple of network segments in our HR zone. The objectives are to allow PCA and PCB, each of them are in a different subnet there, to FTP to server C using a custom application set. We want to deny other users in the HR zone from using FTP services in the 1.1.70/24 network, and we'll log and count any attempts to use FTP. Okay. So let's look at a policy. So here we go. Show zone, security zone. So we've got a HR zone. What we need to do first up is, because we're going to be using some specific IP addresses, we need to put those into our address book right there. So we have got, what have we got there? We've got PCA on 10.1.10.5, PCB on 10.1.20.5. We've got, they're both /32s, and we've got all 10-1, and that is 10.1.00/16. That takes in the whole of those subnets over there. Okay, and we've got a couple of interfaces in our zone. So that's our address book that we've set up there. We've got an address set, which is called HRPCs, which is PCA and PCB. So the benefit of setting up that address set means that we can simply reference the term HRPCs in our policy, and that will include PCA and PCB. Alright, so that's our HR zone. Is our public zone. We've got address server C, there it is, with 1.1.70.250/32. We've got everything else in the zone referenced by the address all 1170, and we have got an address set called address public, and we've only got one server in that. It's server C. Probably didn't really need an address set because we've only got one thing in there, but we have it anyway, as it is. Okay, so this is our application. We're creating a custom application here called HR Telnet, protocol TCP, source ports. We've got a range of ports there, and we've got a destination port, which is Telnet. And we've got an application set, which is HR public application. So we're creating this application set, and again, this is just for efficiency of use in the policy, in that we don't have to create lots and reference many applications in a policy. We can reference an application set. We've got GNOS FTP, GNOS IKE, and HR Telnet. Okay, so this is our policy now. So it's from zone HR to zone public, and the policy is called HR to public. What we are matching is source address HRPCs, which included PCA and PCB in the HR zone. Destination address is address HR public address, which is the address set which actually included three applications. The action is permit, and then we're going to log session inits and session closes, and we're going to count that. Okay. And then this is the next policy, which is policy other HR to public MAC source address, which was the rest of the subnet destination address, which was all of the public zone subnet application GNOS FTP, then deny, and we are logging session inits and counts. Okay, so the first thing that's going to happen is the policies will be evaluated in order, which is important. So the first thing that's going to happen is the matching on the omitted PCs will actually match first, because that is more specific, and then you've got the whole list of the subnet will be evaluated by the next policy, which will then deny. So your commits will come first, then your denies will come after that. Take a look at the policy, show security policy, policy name HR to public detail, and take a look at that policy there, and all the information about our policy, what's matching on it, packets, etc. See that it's actually, we are using the application layer gateway for FTP in that as well. Source address, destination address, there's our application set, that's our traffic, and that's our policy log there, where we can take a look at inbound packets, outbound packets, and elapsed time. Okay, so in this chapter we looked at the security policy functionality, explained GNOS ALG functionality, described components for the security policy, verified the policies, monitored the execution, configured basic security elements, looked at matching, actions, and scheduling. Some questions: what are the basic components of a policy? So what do we need? Well, we have a context, and that's from a zone to a zone. Has a name, has got a matching criteria, which is source address, destination address, application, and it's got an action. Okay. What is the default action for every policy set? Default action. Default action is actually deny all. That's actually the default action. What is the purpose of a scheduler within the security stanza? Scheduler, and we said that we can set up a policy and we can have it active at certain times and inactive at other times. And how can you reorder policies? What was the command for that? Reorder policies? Was the insert command. Does it to reorder policies. Alright, we're going to take a break right now. It's 2:30. We're going to take a break. And when we come back, what I'd like to do is to take a look at some policies that are actually that have been used, some that I've written various times, and we'll just take a look at some of the components of those, look at address book, look at address sets, and just sort of evaluate those policies and take a look at what they're doing. So let's take a break at this point.